Hello friends, today we are going to learn about the volumetric analysis. We see that today the introduction, titration basics, reaction, endpoint and indicators. Types of titration, acid-base theory and principles. Acid-base titration, non-aqueous titration, precipitation titration, complexometric titration, oxidation reduction titration. And friends, titrometric or volumetric analysis is very important in the chemical laboratories and industries. It is very simple and easy, fast and can be done on site, easily can be done on site. And it is very less expensive. An estimation of content or assay of chemical is also very easy. It is precise and accurate depending upon the method and specificity. And some requirements for the reaction. The better result of the titration, the reaction choose for titration must be completed by 99.9%, that is 0.1% can be unreacted in the analysis, that is approximately 100%. Reaction must be repeat. Analysis shall be performed in a reasonable time period. The stoichiometry must be well defined. And so. Types of titration, precipitation titration. Here in this case, the titrant and analyte react together to form a salt, which is in the solid formation. And then acid-base titration, acid and base to form salt and water, as we say that popularly, and which is sometimes we call it as neutralization titration. And another one is complexometric titration. Here in this case, the product is a complex formation. Redox titration, oxidation reductions titrations. Here in this case, one is oxidized, the other one is reduced. And for these titration reactions, we need primary standard and secondary standards, or primary standard to primary standard also possible. And even secondary standard to secondary standard is also possible. But here in this case, the importance of primary standard is that which can be prepared accurately. The accuracy of the primary standard is very important for the quality of the titration. And why it is a primary standard? The primary standard is, it may be a solid or a liquid. It is easier to make a primary standard solution. If it is a solid, it is more easier and easy to obtain, purify and storage, and easy to dry. Even in the storage, it cannot absorb moisture. It can be purified even for the storage. Inert in the atmosphere, it cannot be affected by the atmosphere. And if it is possible, high formula weight, so that it can be weighed with high precision. Like for example, sodium hydroxide and more salt. The molecular weight of more salt is very high, and due to that, we can prepare it very accurately regarding the more salt. Endpoint detection. This is also very crucial, very important. The endpoint detection is very critical. It is to know the completion of the reaction and accuracy of analysis. The first one is visual indicators. Here it is the most common in the chemical laboratories, like in the institutions. Observation of color change or precipitation at the endpoint, or reaction completion is identified by addition of external or self-indicator. External indicator is added in some cases, but in some titration it is a self-indicator. Photometry. Here one instrument is needed for the endpoint detection, which is a photometry, and another one is electrochemistry. This is the best result. Potentiometry, amperometry and conductance. Potential, it can measure the potential of the reactant, the reaction. And then the amperometry can also determine the ampere, the current produced between the two electrodes in the reaction solution. And the conductance, here it can measure the conductivity changes of the solution. Acid-base titration. Acid-base titration is also known as neutralization titration, and it indicates that it is used as indicators, and some mixed indicators also sometimes it is used. And in the neutralization curve is something like this, when here in this case we are adding the titration, and after some time the color was changed rapidly, and after that the color is always permanently changed. And here in this case, when you see the NaOH and HCl, NaOH, when we add it here, HCl is a reddish color, and then after some time this color will be changed to colorless, and that will be the endpoint. But here in this case, when the color is changed, then there is some little addition of this sodium hydroxide is needed. That's what the endpoint is not actually the equivalence point. Principles of acids and bases. We have three popular acid and bases theories: Arrhenius theory, Brønsted-Lowry theory, and Lewis theory. They all have almost the same concept, but in the Arrhenius theory, the acid and base can be differentiated by proton and hydroxide ions. And in the Brønsted-Lowry concept, it is a proton donor and proton acceptor. And in the Lewis concept, electron acceptor and electron donor. When the Brønsted-Lowry theory of acids and bases is concerned, it is a conjugate acid-base theory. Sometimes we call it as like that. Here in this case, a base is react with an acid to form another acid and another base. Here in this case, if this base is a strong base, the conjugated acid will become a weak acid. And if in the reactant part is a weak acid, and the conjugate base will become a strong base. That means strong base will form weak acid will form strong base. Lewis theory of acids and bases. In this case, acid is an electron acceptor, base is an electron donor. Here in this, BF3 is an acid, NH3 is a base. It is because of that, here in this BF3, vacant orbital is there. It can easily accept a lone pair of electron which is present from the ammonia to accept it here and to form a chemical bond, a new bond. And this product is, we call it as a duct. The pH can be calculated easily. pH is equal to minus negative logarithm of hydrogen ion concentration. Here is the pH variation is there. I'm not going detail in this about this. And then here is the buffer equation. Henderson-Heisenberg equation is pH equal to pKa plus log conjugate base concentration divided by weak acid concentration. Weak acid and its conjugate base can be used. A buffer solution. Buffer is the substance which doesn't change its pH when a small amount of acid or small amount of base is added to the solution. It is very important even in the daily life and even in the human living. Here we see that the strength of acids and bases, 7 is the neutral point, then less than 7 is acid, and more than pH more than 7 is the base or basic, or we can say that a strong alkali, a strong base. Here are some of the common juice and some of the common things with their pH. You see, stomach juice is about pH 1 to 3, and human blood is about 7.3 to 7.5. Lemon juice is 2.2 to 2.4. Like that. I'll not go for all. And the end point. What is an endpoint? Endpoint is the change in the color of this titration. When the color was changed, we can say that it is an endpoint. But endpoint is not exactly, as I already mentioned, exactly same with the equivalence point. Point of neutralization is equal to equivalence point. But here in this case, for those of the change in the equivalence point is less than those of the color, those of the endpoint. Because of that, for change in the color, we need some little amount of the titrant to be added to the analyte. Acid-base indicators. Acid-base indicator are a weak acid or a weak base. When it is added to acid, it forms a different color, and when it is added to a base, it forms another different color. Then the color change is used for the identification of the endpoint. Here some of the common indicator, acid-base indicator with their pH, the color change with their pH. This is the titration curve regarding the strong acid versus strong base. I'll not go in detail here in this case. And this is the weak acid versus strong base. And non-aqueous titration. Non-aqueous titration is the titration which is almost same with the acid-base titration. But here in this case, the analyte is not, or the titrant cannot be soluble in water. It is soluble in other solvent. That's what we are calling non-aqueous, without water, without involving of the water. The theory is same with acid-base titration. And then the other one is precipitation reaction. Precipitation titration. Here in this case, the endpoint can be detected by the formation of the precipitate. And so on. I'll not go detail. This is the titration curve for the precipitation titration. And another one is complexometric titration. This titration is important for those of the water chemistry. Calcium and magnesium estimation in water is the most common one for the hardness of water. And this is redox titration, which is used for which is very common in many of the titrations. And then this is the calculation. Normality or molarity. Normality is equivalent weight divided by 1000 ml. That is 1 normal, or one equivalent weight. One equivalent of the substance is dissolved in 1000 ml. That is 1 normality. Molarity is also 1 mole per 1000 ml. N1V1 is equal to N2V2 is the relation what we have. That is principle of equivalence. From this, we can easily calculate the strength of the unknown or the weight of the unknown sample. Here are some of the common errors which is taking place during the titration. Thank you.